Hello everyone, welcome to this lecture video. In this lecture video, we're going to discuss about the paging, how the paging in the storage management using in the operating system. So let's have the paging is a physical address space of a process can be non-continuous process allocated by physical memory whenever the latter is available. So it divides the physical memory into a fixed size blocks called frames. So dividing the physical memory into a fixed size blocks called as already we have discussed as a frames and pages. So dividing logical memory into blocks of same size called as pages. Keep track of all frames. To run a program of size n pages, need to find n free frames and load a program. So to set up a page table to translate logical to physical address. So backing store likewise split into a pages, still have internal fragmentation. So paging having the this kind of things are the introduction part of operating system here. So paging we have the address translation scheme. In the address translation generated by CPU divided into page number and page offset. Page in this picture we have the P as a page number, D as a page offset. Page number B is used as an index into a page table which contains the base address of each page in a physical memory. So the page offset D combined with the base address to define the physical memory address that is sent to the memory unit. So it is a given logical address space 2 power m and page size 2 power n. So these are the things we having the address translation scheme. So paging hardware we having the CPU, page table, logical address, physical address, and physical memory we having. So CPU having the page table as a thing we having. So logical address and CPU we have the physical address also having the this kind of process. So physical memory we have the P and T having the physical address and logical address. Page table generally the CPU connected to the page table, then it will be a direct connected to the physical memory. So in between the logical address and physical address transferring the process from one to CPU to memory. So paging hardware have the using this kind of concept for a page table to have the reducing the main memory unwanted usage of memory will be reduced here. So paging hardware can be able to see in this picture. So in this paging model, uh, paging model of logical physical memory. So logical memory is a page started with 0 1 2 3 4 up to logical memory, and page table will be a numbers will be a would like to be a 1 4 3 and other 7 and etc. So page table can be a process. We have the things we are able to see in this slide. So frame number page 0, page 2, page 1 and page 3 you have the physical memory. So from this we having the main storage management system having the paging model of logical and physical memory we are able to see here. So the paging example we can having the example of logical memory and page table and physical memory. So we can able to having the 0 to 1 to 3 4 5 6 7 up to A2 logical memory and page table we having. So paging example we can able to n equal to 2 and m equal to 4 and 32 byte memory and 4 bytes of pages here. So paging example we can calculate in the continuous things. The free frames in this free frame in the picture we can have the kind of allocation we can able to see in the screen. Before allocation the paging will be a new process. Frame list will be some values of 14 up to 15. The page frame will be a 20 0 and 1 2 3 etc. So in this new process we having the 13 14 15 up to the n number of process here. So free frame list we having the things. So new process page table page 1 0 2 3 etc. So this kind of process we able to clarify in the things. So new before allocation and after allocation we having these kind of free frames. So from this implementation of page table we having the implementation by Page table base register, this is nothing but PTPR, and page table length register is a PTLR. So indicates the size of the page table. In this scheme, every data access requires two memory access. So associative memory or translate look asset buffers. So two memory access problem can be solved by use of special fast look hardware called as cache or associative memory. In this lecture video, you can able to see discuss the few things about the paging concept in the storage management. Thanks for watching. Thank you.